Page 5 is the area of the shaded region. And no, I'm not going to ask you to graph it like your book does, but I will provide you the graphs.
Can I just do B?
The biggest thing that you want to do, unless the graph is automatically in color, is that you want to look at, here's the shaded area, so you want to find it between these two. And I'm going to make one of them a different color, and that's going to be the square root of x. And this one is x cubed. The problem that I have now, because there's nothing marked on the axis, I don't know where this guy stops. So I know it's going to be the integral from 0, and I don't know what that top number is. I need this guy. So what do I know? It's where they intersect. So I need to find, in this case, question mark, by taking these two functions and setting them equal to each other. This is where x cubed equals the square root of x. Now there's a couple of ways that you can go about this. Is that since this is a radical, we'll see what happens. I can clear the radical by squaring both sides. Now this is not how I did it previously. This says that x to the 6th just equals x. Bring everything to the same side, 0 on the other. Greatest common factor of x. This says that x equals 0. This says that x to the 5th minus 1 equals 0. X to the 5th equals 1. Take the 5th root of both sides, and since it's an odd index, I don't need the plus or minus. So x is just 1. So this question mark is 1. So the limits of integration are from 0 to 1. And actually my pen is purple. You probably can't tell it's purple, but it is purple. This darker top, the above function, is the square root of x. So it's upper minus lower. And the bottom one, this red guy, is x cubed. Now this is strictly anti-power rule, because that's x to the 1/2 minus x cubed dx, which is x to the 3/2 divided by 3/2, so that becomes 2/3, minus x to the 4th over 4, evaluated from 0 to 1. I love 0. Well, why? Because this is 0. So this bottom one's going to give me 0. So it's just the guy from the top. But I'll put that in anyway. So it's 2 times 1 to the 3/2 over 3 minus 1 to the 4th over 4 minus the lower is 2 to the 0 to the 3/2 over 3 minus 0 to the 4th over 4. And so notice that this happens to be 0. These are 1s.
Where did you get the 2x to the 3 over 2?
Now remember that this is going to be x to the 3/2 divided by 3/2.
Okay, so
Right, so you're going to flip the fraction.
okay, thank you.
Yep. Always good to pull me back. So 2/3, because 1 to the any power is 1, minus 1/4. Now you can do one of two things. You can use your calculator. So 2 divide 3. Oops, you can't even see, you can't see that. Minus 1 divide 4 is that. Now if you want a number, by the way, you can go to math and then push it to a fraction. It's going to be 5/12. Or we can do it the hard way. This is 4/4. This is 3/3, which is 8/12 minus 3/12, or 5 divided by 12. So that's the area that's under that curve. That's between those two. Anything else? You okay with that, guy?
At the beginning of that, I'm sorry, I kind of meant y of x to the third equals square root of x. To find the question mark 1.
No, the square root of x is here. Oh, you mean this? Because I needed to know where this guy stopped.
Yeah, I don't get why that
And
was.
where that is where these two graphs are equal.
Okay.
Okay, this is and essentially and this is the intersection. Or the x value of the intersection. So I need to know where that guy stops. Well, what is it? It's where the two y values are the same. So what they have is a shared x and y value. Where they intersect, they share that coordinate point.
Okay.
So you go after what is the x value that they share. Does that make sense?
Yeah.
Yeah. Now, if it's there, like it is, if it would be here, you're given the values. So sometimes it's obvious. But the problem that we have is we have no markings on that axis. So we know that's 0. Haven't a clue what that is. Because we don't know what the marking is on the axis.
That makes sense.
So then you have to go after it. Now that's what's going to happen when you go into after this class. Now if you were in a course called linear programming, you'd always be looking for what they call the vertices, which would be the intersections of the graphs. And the vertices, like if I had a bunch of lines that intersect, right, I would go after what are the intersections of those lines. The intersections of those lines would give you maximums and minimums of things. So what happens in linear programming? But I'd have to go after the intersection. Well, what would it be? It would be where those two functions or two lines intersect. So in this case, what would the upper limit be? Because I don't know what it is. It would be essentially where this guy stops. Whoops, I got my arm in the way now. Where this guy stops. Okay, so if it's obvious, that's great, but sometimes it's not obvious. In this case, it wasn't. It wasn't obvious. I do want to do one more, and I'm just going to look at a setup. Suppose what I have is I have a line, any line. And I have a function. And I'm going to call this graph y1. And then I'm going to look at a function and I'm going to call that y2. And this is what I want. Now, this would be, I'm going to make up some values as I come across. And normally what you would say, well, I take a look at this, and this maybe is going from -1, which looks reasonable, to 5. And I want to find this area. What you have to do is to realize that in this particular case, y2 is the function that's above, y1 is the function that's below. Then what happens? At this point right here, y1 moved above and y2 moved below. Because remember, it is always upper minus lower. This may have occurred, say, at 2. So if I were going to set this up, I'm just going to do a setup. What would it be? Well, I'd start at 1, -1, and go to 2 because y1's above. And y2 is above, y1 is below. And since these y's are a function of x, and then I would take this area and add it to the second area. This time y1 is above and y2 is below. And I'm adding the two areas. Do you see how that works? When you have functions that tend to, you have to take a look, and that's why lots of times you see me go over a function and change its color. And say, oh, wait a minute, here the red one's above and the blue one's below. Here the blue one's above, but the red one's below. Because they actually changed positions. That's how you would set this thing up. Any questions on how this works? I didn't give you one on the review, but that would be the setup. And then you would do just the regular integral. Find that area, add it to that area. Any questions on that? I think I did one that, if you go back to the note packet, I did one in the note packet. But I just wanted to remind you, just in case. No?